Okay, we're rolling.
Okay, so my name is Erik and I'm the creator of not the RUFS system, but I'm the designer of the Arduino for the RUFS system. So something that you need to learn first of all is hydroponic gardening. Hydroponic gardening is gardening without soil. So what you're doing is you have a tank of water, or I guess it's a nutrient solution that has the minerals required for plants. So you don't need soil to contain the water and the nutrients. You have it in the water. So the water runs through the plants or sits in the plants, and that's how they soak up their nutrients, which is actually, if done properly, it's much more efficient and yields much larger crops and much faster time span than conventional gardening. So some things that make it so efficient and yields such high yields, I guess, is the fact that you're monitoring things such as pH, the light levels, and temperature and humidity, and other values. So what I've done here is I've used the Arduino and I've used the Ethernet shield along with a DHT11 and a pH sensor to create a mock-up of this. This is only phase one. So some troubles I had while doing this was originally I wanted to get a water level sensor to measure this, and some other pumps called peristaltic pumps that allow you to manually or automatically feed in pH or acids and bases and the nutrient solution, so you can manually control the environment of the tank. So I'll turn it on right now, show you guys. So right now there's a tank of water right about here in this 5-gallon bucket, and it's feeding water in here. So what you would have is the plants in here. I don't have any plants in here right now, and the water would drip down through the plants and then it's soaking up through the roots, and then it just falls back down and collects. So right now what I have is there's a pH sensor connected to the Arduino through this chip that allows you to measure the pH. The pH is very important because that's the main thing to determine whether nutrient solution is too much or too little, because plants have a very specific pH area that they grow best in. So if you can keep it in that area by adding acids and bases in the nutrient solution, then you can really increase the yield of your plants. So one more thing I have is this DHT11 sensor in here. That's currently measuring the humidity and the air temperature. And that's very important because humidity for plants, the best humidity is around 50 or 60%, and that's yielding the best results. Of course, in here it's air conditioned, so you can't control that. It's 38%, so that's pretty close, but you can't control that in this environment. So that's really not too big of a concern for this demonstration. So this Ethernet shield right here, what it allows you to do is it allows you to upload the sensor data from this thing anywhere. As long as you're connected to the ILNet, you can log on to this IP address, 10.20.7.202, and get this data, which is actually updated in real time. So the real time pH or air humidity or air temperature right here. So if I log onto my phone, which is connected to the ILNet, I am receiving the information from the client right here. So originally, what I wanted to do, as I said, was be able to control it from the internet, but unfortunately I didn't get the pumps that I needed because of budget restraints. But one thing I was able to do was I was able to get it so you could log the data and export it to this such as Excel, and you can graph it, which I can do right now. So all I'm doing is unplugging it and taking out the SD card, which has been actually logging data this whole entire time. So I'll plug it into here, and since this is a relatively controlled environment with no plants in it, you should expect relatively stable numbers. But I'll show you right here. So what I'm opening up here is, this is a log of the data it's been keeping this whole entire time. So every single time the web page reloads, it tracks more data. So for the last 30 minutes or so, it's been recording this data for you guys to see. So all you have to do is just copy and paste the data into the program such as Excel, and then we'll be able to graph it. So right here, here's a graph of what has been happening for the last 30 minutes for this whole entire setup. So of course the air humidity and the light, since this room is conditioned, hasn't changed, and the pH has stayed remained the same because there have been no plants and no nutrient solution has been added to it yet. And this jump that you see here, the first couple times the pH sensor turns on, its readings are inaccurate because it has to calibrate itself. So this was just phase 1 for my project. Phase 2 will include, so this is just a showcase of the sensor technology that I've made. Stage 2 will include a 6-foot-high growing station, I guess, that I'm working on with the EcoAction team. That includes like 20 or like 50 or so plants that all can be monitored based on this system. So So in addition to just learning how to do this, it's been a learning experience because I had some delays on my parts, and that's really taught me how to budget my time while I have when I don't have parts I'm received. So what I did when I didn't have my pH sensor, that's a large thing I was waiting on, and the pump. So when I didn't have that, I was working on the HTML, the formatting of the server so I can make it look nice. And during the time I was waiting, I actually worked on, even though I wasn't able to incorporate everything I had hoped to accomplish here in this current system. So what's inputting? This is what a final edition of the web client after I've added the pumps and been able to export data should look like. So this would allow you to give you the data, and then you'll be able to pick dates and times to export the data and be able to copy that out to whatever graphing or like table application you'd like. So yeah. Any questions?
Okay, questions for Eric? I'll throw you a grapefruit. How many of these are you planning on making?
2.
2. Where would they be situated?
So one would be situated, so they're being made by the EcoAction team. There's 2 groups, there's 2 kind of teams that are working on this project here at the Hill. And some kids from OJ are coming in to work on it. So one will be situated in the greenhouse, and one will be situated at, not OJ, I apologize, at Pottstown High. So I'm not exactly sure where that will be placed, but they'll place them in respective areas. And hopefully by the end, we'll have it'll be made so anyone in the whole world can create this and upload their data to a website where it can be compared.
Cool. Any other questions? Okay. Thank you all. Good job. Stop the video recording.